All right, so DeepSeek V3.2 and Gemma 4 are both making serious noise right now, and I ran them through 4 real tests to see who actually holds up. Gemma 4 hit 80% on live code bench, while DeepSeek came in at 59.3%. And that gap is pretty hard to ignore. Both models dropped in 2025 and 2026, so this is super fresh, and I'm comparing them across 4 concrete tests: reasoning, inference speed, context window, and local deployment, all from sourced benchmarks, no vendor spin, no made-up numbers. And honestly, the thing that surprised me most is which model you can actually run on your own hardware without spending a fortune. And the answer is way less obvious than you'd think. So this one's for developers and builders who need to pick a model and actually commit to it, whether you're running an API-heavy workflow, want something local on a mid-range GPU, or need to chew through 200-page documents. Pick the wrong one, and you're either paying too much, hitting VRAM walls, or getting worse code than you expected. Test 1 reasoning and coding accuracy. Get this wrong, and your generated code ships bugs, your science reasoning hallucinates steps, and you spend hours debugging output that looked confident, but was just wrong because bad reasoning doesn't announce itself. It just breaks your pipeline downstream. I looked at the numbers across MMLU Pro, GPQA, and Live Code Bench. And on MMLU Pro, it's close. Gemma 4 at 85.2% versus DeepSeek at 83.7%. But on science reasoning, Gemma 4 pulls ahead at 84.3% versus 75.1%. And on Live Code Bench coding, that gap gets really wide. 80% versus 59.3%, though these come from different evaluation setups. So treat them as directional. Now, before I call this, there's a real caveat. DeepSeek V3.2 scored 96% on IME 2025, math, and 1 old at IMO, IOI, and ICPC, which is genuinely hard to argue with, but those scores come from different competition years than Gemma 4's figures. So clean math head-to-head isn't possible. And the coding and science gaps are pretty consistent because they're on the same benchmarks. Gemma 4 takes test 1, and I was honestly expecting DeepSeek to be closer on coding given all the hype. But a 20-point gap on Live Code Bench is not close, and Gemma 4 is just cleaner on code and science reasoning by the numbers we actually have. So the score sits at Gemma 4 1, DeepSeek 0. Test 2, cloud and on-device inference. Slow token output in a production app means users watch a spinner, too much VRAM, and your local setup just doesn't boot. And if API costs spike because throughput is low, you're burning budget on latency rather than actual work, which is why speed and hardware fit are where theory meets your real monthly bill. What surprised me here is how different these two models are in deployment profile. DeepSeek V3.2 hit 230 tokens per second on DigitalOcean Cloud with a time to first token of 0.76 seconds on Vertex. Gemma 4 has no published cloud equivalent, so I can't compare directly there, but Gemma 4's E2B and E4B variants run on phones via LiteRT LM, which DeepSeek just can't touch at any size. Picking one winner here would honestly be misleading because these models are targeting completely different hardware tiers. DeepSeek's 32 billion distill runs on a single RTX 4090 at 30 to 38 tokens per second, which is pretty solid, while Gemma 4's 31 billion dense needs 69.9 gigabytes of VRAM. So that's a multi-GPU setup. But then Gemma 4 also runs on a phone, so these aren't really competing for the same user. So test 2 is a tie. And I was expecting a cleaner split, but the data just doesn't support one winner because the use cases don't overlap. DeepSeek dominates cloud throughput, Gemma 4 owns mobile, and neither is wrong for what it's built for, so the running score stays at Gemma 4 1, DeepSeek 0, 1 test tied. Test 3, context window and long document handling. Be it a 50-page contract or a full code base into a model with a window that's too small, and it just truncates so you get a confident summary of half the document. And that's not a minor inconvenience, that's a real failure mode that corrupts your output without warning. I went through the published specs. And Gemma 4 comes in at 256,000 tokens, confirmed across all sources, while DeepSeek V3.2 is a little murky. Official sources say 128,000, but the Hugging Face card lists up to 160,000. So either way, Gemma 4 is roughly double, which works out to about 384 pages of English text, versus 192 at best. And Gemma 4 adds 140 plus language support on top of that. Now, DeepSeek's DSA architecture does something genuinely interesting. It cuts long context compute complexity by roughly 50%, which also delivers 2 to 3 times faster inference compared to V3. So within its window, it's more efficient, but that's an efficiency win inside a smaller box rather than a box size win. And the conflicting 128,000 versus 160,000 spec is worth knowing before you build against it. Gemma 4 takes test 3. And I was expecting the DSA efficiency story to make this closer, and it kind of does on cost. But raw window size is what matters when your document doesn't fit. And double the context is double the context, so the running score moves to Gemma 4 2, DeepSeek 0, 1 tied. Test 4, open weight accessibility and local deployment. Pull the model, your GPU runs out of VRAM, and now you're either buying new hardware or paying for cloud anyway. And if the license has restrictions you missed, your commercial product has a legal problem you didn't budget for. I went through the deployment specs, and both models are genuinely open with commercial licenses, MIT for DeepSeek and Apache 2.0 for Gemma 4, and both work with Ollama. But here's where it splits. DeepSeek's 32 billion still runs on a single RTX 4090 at 30 to 38 tokens per second. Gemma 4's 31 billion dense needs 69.9 gigabytes of VRAM, and Gemma 4's E2B and E4B variants run on phones, which is a completely different tier. Honestly, the openness story is a tie. Both licenses are permissive, both have Ollama support, and community-reported setup times are similar at about 5 minutes for DeepSeek via Ollama. So what actually separates them is hardware tier. And if you need mobile or laptop deployment, Gemma 4's small variants are the only option. Test 4 is a tie. And I went in thinking one of these would have a clear edge on accessibility, but both are genuinely well supported, and the hardware split just makes them serve different users. So the final tally lands at Gemma 4 2, DeepSeek 0, 2 tests tied. So here's where DeepSeek V3.2 wins. No hedging, elite math at 96% on IME 2025, and gold medals at IMO, IOI, and ICPC. Cloud throughput up to 230 tokens per second at prices as low as 29 cents per million tokens blended. And mid-range GPU local deployment, where the 32 billion still runs on one RTX 4090 and the 14 billion fits in RTX 4080, which is genuinely accessible. And here's where Gemma 4 wins. Coding and science at 80% on live code bench versus 59.3%, a Codeforces ELO of 2,150 with no published DeepSeek equivalent, a context window of 256,000 confirmed versus DeepSeek's disputed 128,000 to 160,000 mobile deployment via light RT-LM, and 140 plus languages built in. Honestly, I went in thinking this would be closer overall, but Gemma 4 is the cleaner pick for most builders. So here's the decision rule. If you're literally hammering cloud APIs for math-heavy or agentic workflows on a budget, DeepSeek V3.2 is genuinely compelling at 29 cents per million tokens and 230 tokens per second. But if you need to run on a phone, handle 200-page documents, or write production code, Gemma 4 is the one.